Okay, so this is going to be a quick video looking at empirical formulas. I'll have a follow-up second video on how to go from an empirical to a molecular formula. But an empirical formula is just the lowest whole number formula for a molecular compound. So if you look at, for example, CH4 is an empirical formula with one carbon to 4 hydrogens. That would be the empirical formula for all of these molecules because they all have that same 1 to 4 ratio. So these might be different molecules that exist naturally, but they all would have an empirical formula of CH4. To calculate an empirical formula, basically what you're going to do is you're going to be operating from the percent compositions of the compound that you're given. And what you do is you pretend that those composition percentages are grams. So if you have 100 grams total, whether or not you actually have 100 grams, you can say out of 100 grams, the percentages would then be grams. I'm going to kind of just walk through this example at the bottom to show how to do this. So we've got some methyl acetate, and you're given the percentages here of the components that are carbon, hydrogen, and oxygen. And if these are the percentages, we're going to just say, so out of 100 grams, 48.64% would be 48.64 grams. So for carbon, we're going to say 48.64 grams of carbon, 8.16 grams of hydrogen, and 43.20 grams of oxygen. So that gives you the ratio of those percentages and then the masses. Then what we're going to do is we're going to convert those masses to moles. So to convert grams of carbon to moles, you would have to divide by the molar mass of carbon, likewise for hydrogen and oxygen. So once you divide by the molar masses, that gives you the number of moles of the three components. And at that point, you can compare them directly. We want to find that mole ratio. So the way you do that is you divide each of those values for the moles by the least amount that you're given. So the least amount is the 2.7 moles of oxygen. So we're going to divide the carbon's 4.05 moles by the 2.7, the hydrogen's 8.08 moles by 2.7, and oxygen's will of course be 2.7 over 2.7. So then you get these ratios. I'm going to call 2.99 close enough to 3. So I've got a 1.5 to 3 to 1 ratio. Now, if I'm going to write an empirical formula, I can't write C1.5. It's got to be a whole number. And that's where this part up here comes into play. So if you end up with a decimal for your ratios, you're going to have to apply a multiplier. If you have a 0.5, you can double it to always get a whole number. If you have something that's a 0.33, you can triple it to get a whole number. And a 0.25, you can quadruple it to get a whole number. So down here, since we've got a 1.5, we can double that to get 3. But if we double the carbon, we'd have to double everything else. So doubling the hydrogen and the oxygen. So then we get a 3 to 6 to 2 ratio, which means that the empirical formula is C3H6O2.